Hello everybody, I'm Storm here. Welcome back to Kerbal Space program. In the last episode, we sent up a SSTO to exchange crew with the returned KSS Ballista. So we brought the crew that went to Duna home and replaced it with, I guess, what you might call a skeleton crew, just to keep the science lab running and to provide a pilot for the vessel that will be able to fly it over to the moon and dock it up with the Kerbal 1 station for refueling and servicing. At least that's the plan anyway. I haven't gotten around to actually doing that yet. So that's kind of still in the cards. I gotta get around to doing that. It probably won't be doing it on screen because it is a painfully slow process. I've kind of tested a little bit how that's going to work, and yeah, once we're like in physics range at the Kerbal 1 station, it is a painfully slow process that everything just grinds way down. But you know, that's kind of the only way that those vehicles are going to be viable, I think, is being able to refuel in situ or in space at a service station, which is what that station's supposed to be, and then head back out. Then we went ahead and unlocked a bunch of technology. We've got all this unlocked, colossal rocketry, worked on all the nuclear propulsion, got the brand new Deliverance atomic aerospike rocket, which I was looking at trying to see if we could use. I kind of quickly threw together a little experimental vessel. It was a bit goofy looking, using the giant spherical tank. So yeah, there's an option. And so that's kind of where we're at the moment. Planning a trip to Dres, because that window is just about open, and we haven't even so much as sent an unmanned probe there yet. So it's completely unexploited science available there. Now, the thought would be, do I send a fully manned vessel, or do I send an unmanned probe to Dres? I was thinking about that particular question. And I'm thinking, actually, that I'm going to go ahead and send an unmanned probe to Dres. Because I was experimenting with these atomic aerospikes, and they're good. They're really nice. They have a lot of thrust. They have good specific impulse. But I still think for like the bigger vehicles, the plasma engines are still better. You know, not as quick to accelerate, but just their specific impulse, and you know, the bang for buck you get out of them is better. So neither of the current vehicles that I have are ready for another flight. So I'd have to probably build another one if I were going to do manned, or design something new. I do want to design a new manned vehicle. I have some ideas for something kind of crazy, and we'll get to that. But I think that getting an unmanned probe out there first is going to be better, and then we'll get back there eventually with a manned vehicle. An unmanned lander might be interesting to try. So let's look at the work and see what I can come up with. The other thing that I want to do is I want to test out the new nuclear pulse engines that we have. I think it's the Orion and the Medusa. Where are you? See, there's the Emancipator atomic rocket motor. That has a thrust in vacuum of 1500 kilonewtons with a 2850 specific impulse. This atomic aerospike has a thrust of 4000 kilonewtons with a 500 specific impulse. So this is kind of like a first stage atomic aerospike with just massive amounts of thrust. And then you've got this guy, which I guess you would consider an upper stage, and has half the thrust, less than half the thrust, with more than double the specific impulse. So, it's a thought. Oh, there's the nuclear pulse. There's the Medusa. Where's the Orion? There's the Orion. Interesting. This one's a bit more compact. Ablative oils. It has 1,000 ablative oil on there. It uses up 0.001 per second. So that's a lot of seconds. Okay. But it means that it's like not a infinitely operable engine. It will eventually wear out. Huh. Now there is this guy, Orion Pulse Unit Magazine. NPU 250. NPU 1000. I'm not really sure how that works. So this thing deploys. Well, that's interesting. Huh. I've really got to see this thing in action. Hmm. (917 meters per second). I think I just need to go ahead and put one of these things in orbit and see what it does, because I haven't even begun to understand how this thing is supposed to work. Well, that's a rather large piece of equipment. It's 5 meters in diameter. Alright, do I have an adapter that will reduce That's a tank. I don't need a tank. I just need like an adapter plate like that. Alright, let's put that on there. Let's throw a battery on here. And I'll need some sort of solar panels. Which, did I get the super solar panels yet? No, I don't think I did. These will do, I think. We might need to move them a little bit further down. Okay. And let's put a big antenna on it. Because if this works as well as I think it might. Is this a relay? No, this one's direct. This one's relay. I think I'd want it to have a relay antenna. Sure, why not? Alright. And you know what? Assuming that this thing actually does something, let's throw... No. We'll just leave it like this. We'll just leave it like this. And then we'll throw as large a decoupler as I can on here. Okay, so how am I supposed to attach anything to this? So I could do that. Nothing seems to want to attach radially. Alright, well, what if I were to switch over to the actual Orion drive? But I really want to see what this Medusa is going to do. Alright, well, what I might need is some sort of structural part that is 5 meters in diameter. Do I have anything like that? I do, in fact. Well, that's very convenient. Okay. Let's make that a solid core. And then we'll throw these guys on here. Okay. Then what this might need here is an RCS tank. Not a very large one. With some RCS blocks on it. Okay, RCS blocks. Just enough to get it to maneuver around. Okay. And then for structural, what we're going to want are these guys. No. Those struts are way too small. That probably much larger than I need. These? Those, I think, could work. Okay. See, the thing is, I don't have any kind of, like, omnidirectional block. This is a bit of a strange way to try to do this. But it might actually work. This is going to be really strange. And then I would use one of these. There. Ooh, let's flip it out. Okay, there we go. So I don't think those are lining up exactly right. No, they're not. Well, we'll see. We'll see. And then I can use my adapters to adapt out to 5 meter. And then I have a 5 meter fairing. This is going to be an enormous fairing. Oh, hold on. I don't have enough working room here. I have to bring this down a bit more. Clamshell deploy, build the fairing. Okay, there we are. So that's 173 tons that we need to throw into orbit, just as an experiment. Okay, well, I think we can make that work. And what I think we're going to do is we're going to use these atomic air spikes to make this work. And to that end, what I want is the largest hydrogen tank we can get using isosahedral. Alright, let's see what I can get with this. We're going to go ahead and make this a LH2 tank. An LH2 tank. We're going to use this. Oh. That's a 3.75 meter engine. I might have an adapter for that. No, that one is much too large. What about this one? Do we have 1 times... Well, that's 1 times 2.5 meter. Does that fit? That actually fits. Okay. That's fine. How much delta V does that give me? Oh, what are these? Oh, those are those guys. Okay. That gives me 785 meters per second. The thrust to weight ratio of 0.87. LH2. Boat tail 2.5 meter. Boat tail 3. Oh. So it actually does have a mount that covers 3.75 meter. Okay. Well, that's fine. There we are. Okay, good. That's the fairing is going to the right place. That's what I was concerned about. Okay. Now, I'm gonna need to go procedural tanks here because I want to use something rather ridiculous. I just want to see what it does. Liquid tank, procedural liquid tank. We're going to go for a diameter of... Actually, we're going to do a cone. Top diameter is going to be 5 meters. Bottom diameter is going to be 7 meters? 7.5 meters? Is that right? Let me just check. I want to use this adapter. Yes, 7.5 meters is going to be right. Let's make it 3 meters in diameter. We're going to use cryogenic orange. And you are going to be liquid hydrogen only. And then procedural RCS, cylindrical. We're going to make you, let's say, 10 meters tall? Cryogenic orange. We'll throw this big adapter down here. There we are. And you're using what? Upper mounts, 3 times 1. We want 2.5. 3 times 2.5. Lower mounts, I want... Do I want 1 times 2.5? Maybe. I'm not sure I'm actually going to need that. Just go none. And then for engines, we will use these guys. Those are 3.75 meter engines. They're not going to work. I can use these guys. What are we getting? 0.78 thrust to weight. Oh, because you're monopropellant. Ooh, that's the wrong type of tank. That is the wrong type of tank. There we go. That's what I need. We need to pull this down here. Okay. Liquid hydrogen. 1.88 with 1,600 meters per second of delta V. That's gonna need probably some boosters. Why not? Boosters it is. This is already the most ridiculous looking thing I've ever built, so why not keep going? Zoom in a little bit. Okay. There we go. What kind of boosters can we throw on here? Some 2.5 meter. I think those are actually 3.75 meters. No, actually, let's go with the 3.75s. Or we just stick with the same look. We get them out to 3.75. We make them, oh, I don't know, 9 meters tall. With some cones on top. Sure. Why not? You're liquid hydrogen. You're mixed. No, we need you guys to be liquid hydrogen. Good, good. And then you guys are going to use these guys to get off the ground. This is going to be the nuke pulse test bed. Save that. Let's see if we can get it to orbit. That's going to be the first struggle here, is get this sucker to orbit. And we'll see if that's even going to work. Let's see, this is 1.88. If I were to add another... another meter there. 1.87. 1.85. Okay, that might actually work. .26, 1.83. I think I need to fire all of these engines at once. So all of you guys and all of you guys are going to have to go at the same time. Okay, well, let's save it and let's see what it does. Let's launch it. Alright, so there's our monster right there. The 7-meter diameter. Seven-meter diameter main core stage. Okay, let's engage the autopilot. Let's see what the autopilot makes of this thing. Let's go ahead and light it up and see what she does. Alright, it's throttling back for max Q. Those are some interesting engines. Alright, the side boosters are going to detach here in a second. They all collided, but whatever, that works. Thrust to weight ratio is at 2.09. The apoapsis coming up nicely. And how much do we have in that second stage? 785 meters per second. I realize here I did not put any kind of control on this, on that stage. So I won't be able to dispose of it. That's unfortunate, but it'll be alright. It'll be alright. I'm not even sure it's going to get me all the way to orbit. It's already almost out of fuel. Alright. Disengage autopilot. Is it disengage autopilot? Thank you. I have 1 minute to do this. Okay. Jettison this. Fire up that engine. Oh, no. Okay. That works. Maintain prograde. Actually, we're going to use the maneuver planner, circularize at the apoapsis, create node. Deploy that. I have no idea what that does. Oh, really? Is that supposed to be the front? I see. Okay, so this is actually the yield. Of the warheads. Why is it still, why is it still going? Okay. Well, at least now I know how that thing works. Can you actually control from there? No. I actually have to flip around the control modules. I see, I see. Which I think this has way more delta V than what it says. Shut down the engine. Okay. Okay. Now that I know what I'm looking at, I think I can make this work. And I am shocked that those solar panels did not blow off. All right. All right. All right. Alright. Well, a few things we need to change here. Well, for one thing, we need to change around how this whole thing is controlled. Okay, so I need to put in a remote guidance unit there with its own power supply. And its own solar panels. And its own... Oh, solar panels. Nope, there we go. And its own... reaction wheels. This is a big, heavy stage, so we're going to go with multiple reaction wheels. Alright, so this thing should really be the final push into orbit. So we're going to need a lot more kick out of this lower stage. And I think I have a plan for that. When in doubt, more boosters. Okay. And I'm going to go ahead and asparagus stage them and see if that helps. Asparagus staging is where we chain the fuel pipes like this. Okay. So then what'll happen is we'll light all these engines. Do I need to light the center engines? No, I don't think I need to light the center engines. Okay, so put the center engines in their own stage. And they're going to go like this. And then what we're going to do is we're going to sever these guys first. And then those guys. And then light the center engines. And that will get me what? A little bit more delta V. 3,829. So about 600 more meters per second. 3,000 meters per second in just this staging alone. All right. Now, up here... what I need to do is I need to take this off. I need to take that off. I need to flip that around. Oh, you're really going to do that to me? I lost the attachment point. Alright, so now that should be oriented with this end of the craft forward. RCS thrusters. This whole separation system worked very well. Well, I wouldn't say very well. It worked good enough. And it's going to need a science package that can return. Or at least a science package that could potentially get picked back up or transmitted home or something. All right, so oh yeah, this is a new mod I added in. Different spherical and toroidal fuel tanks. I'll have to play around with this at some point. Yeah, there's a few interesting things in here. Alright, but that'll be for something else. For this, I want to do some goo. Goo containers. Materials science. Gravioli detectors. Thermometers. Barometric pressure scanners, which, you know, that seems silly, but it should work. Seismic scanner doesn't make any sense because we're not going to be landing this thing on anything. Atmospheric sounder. Won't need that. Infrared telescope. No, that's because that's actually not part of the vehicle. Alright, so I actually need to set up an action group for these solar panels. Let's save it. And is there anything else that I can try here? I can probably try to continue to make this longer. 15 meters. Okay, that'll get some more thrust out of that. Let's increase these to 12 meters. Oh, what? Well, that's somewhat annoying. I gotta redo all that if I want to do that. Okay. Well, as long as these are in two separate sets, then it's fine. Let's increase that height there so I have just some more room to work. procedural liquid tank. 3.75 meters. We're going to make you guys 12 meters. Actually, can I make you guys 15 meters? Yeah, 15 meters in height. Alright, we gotta put the cone back on here. Bottom is gonna be that. We're gonna make these 4 meters tall. And they're gonna have just liquid hydrogen. Cryogenic orange texture. See, these things also take oxidizer. So, what if I made these hydrolocks? First stage, 5.31 meters per second. Thrust to weight is better. But we get more overall delta V out of those guys. No, we'll just keep them as liquid hydrogen. $135 meters per second. Fires for 10 seconds. That doesn't seem right. Can I move these? Try and line them up a little bit better. Okay, so which one of these is gonna fire first? Those. Yes, and then those, and then these. Toggle mode. LH2. Automatic switching. Okay. I'm hoping this works. I'm really hoping this works. Because the numbers here aren't making sense compared to what I was doing before. Oh, that's because these have no fuel in them. Well. That would make sense. And if you don't have any fuel in the tanks, you don't get any Delta V out of them. I'm glad I caught that. What about these? Do these have fuel in them? Yeah, they do. Okay, that's why they were going to run for 5 seconds, because only the cones on top actually had fuel. Alright. Save that. And let's put it in orbit and see if we can get that to work. Launch. Alright, there we are. Let's see what it does. 100 kilometers. Engage the auto warp. And let's see how she flies. We've got a lot of spinning going on. That's awfully strange. I think I know what the problem is. We're not controlling from the correct... from the correct part. So it doesn't know what it's doing. And that did not work at all. Okay, well, I'm not going to auto-stage it then. Well, that's a mess. All right, I'm going to go ahead and revert back to vehicle assembly. That's considered a wreck. No crew on board, thankfully. Now, can I somehow tell it to control from a particular one? Control point. Default. Is there any way to maybe get a better, easier to control? So I don't have a 5-meter AI or guidance unit. What I do have is this thing that I could slap on the side. There we go. Now, I do not know why the staging wasn't working correctly. Alright, well, let's save it. Let's try and launch it again. Okay. I'm going to turn off the auto stage. I'll control the staging. Can we control from here? That still isn't great. No, that still doesn't work. Or I could. No, because you can't. Well, actually, I could get that in there. Okay, I have to take it back into the vehicle assembly. I'm going to get this thing in orbit before we end the episode here. Okay, so I'm going to have to do this same thing. Put that on there. Get that on there. Make sure my staging's all correct, which it should be. Save. Go back out to the pad. All right. We're not auto staging. Now, I just need to make sure that we're controlling from the right, the correct. Oh, come on, is there a way to do this? Okay, I just needed to zoom in really, really, really close. Control from here. There we go. All right. Engage the autopilot. Let's go. First set of engines are gonna run out here. Engage those center engines. Second set of boosters are going to run out here in about 10 seconds. There they go. Alright, what's our thrust to weight? 1.92. Apoapsis height is at 36,000. We have 1,800 meters per second delta V left in that tank. I think this is definitely gonna work better. No idea who you are. Alright, Apoapsis height is coming up here. Alright, so we have, what, 800 meters per second left. In that tank. I think I'm going to actually jettison it. And switch to this engine for circularization. Get rid of those fairings. Oh, really? Auto-deploy the solar panels destroyed half my solar panels. Oh, well. It should be fine. That's just really annoying. All right. So there we are. Turn on the SAS. All right, we're going to go ahead and separate. Push us away from that thing. I should be controlling from here, right? Control from here. There we go. Set the prograde. Alright, where are we in the orbit? We're over here. Okay. Let's warp to... Let's warp to this point in the orbit. Now I'll be able to actually come back and fly that thing and get it to re-enter. Alright, go ahead and flip this thing prograde. Okay. Go ahead and deploy the drive. There we go. And let's begin accelerating. This thing's got some acceleration. There we go. Now, can I actually retract that? I can. Electric charge is fine off of a single panel. Oh well, it happens. And I think we got tons of delta V in there. Huh. That is definitely something to think about. All right, but I think we're at the end of this episode. So, we got this guy on its way. This is going to fly by Dres, if all goes well. And... yeah, then we also have the Arbalest on its way to Joule. So we got that mission coming up as well. All right, so for now, hope you guys enjoyed it. Thanks for watching. Go ahead, like, subscribe, and comment, and I will see you next time.